Today we will learn the method for solving simultaneous linear equations. For that, we will consider two equations, and one of which is x plus 5y equal to 11 and the other is 8x minus 3y equals to 12. We label them as A and B respectively. Now before starting, let us understand what is the meaning of the words simultaneous and linear. Simultaneous means that we are solving these two equations to find values of x and y such that they will simultaneously satisfy both the equations. And linear is because the index of x and y is 1. And when we plot these equations on a graph, they becomes a straight line. There are two methods of solving this kind of equations, and they are elimination method and substitution method. We'll start with elimination method. In this method, we multiply or divide one equation by a certain number and then subtract it or add it to the other equation so that one of the variables gets eliminated and we get an equation in one variable. Like here, we have x plus 5y and we can see the coefficient of x in the first equation is 1 and that of in the second equation is 8. So we multiply the first equation by 8 to get 8 into x plus 5y equals 8 multiplied by 11 or 8x plus 40y equals 88. We label this as C. Next, we subtract equation B from equation C to eliminate x. So we get 8x plus 40y minus within bracket 8x minus 3y equals 88 minus 2. If we now remove the brackets, we get 8x plus 40y negative 8x. Now the negative outside and the negative inside of the bracket, they both get multiplied to give you positive. So it becomes plus 3y equals 88. Cancel 8x and negative 8x so that we get 43y equals 86. And we divide both sides by 43 to get y equals to 2. Now substituting y equal to 2 into equation x plus 5y equals 11, we will get the value of x. If we substitute, we get x plus 10 equals 11. So x equals 11 minus 10 or x equals 1. So the solution to this system of simultaneous linear equation is x equals to 1 and y equals to 2. We will discuss the substitution method. Now in substitution method, we express one variable in the form of other using one equation and then we substitute that form of the variable into the other equation to get a linear equation in one variable. Like here, the first equation is x plus 5y equals 11 and the second one is 8x minus 3y equals 2. So from equation A, we express x in terms of y as x equals 11 minus 5y. We then substitute this form of x into equation B so that we get 8 multiplied by 11 minus 5y minus 3y equals 2. In the next step, we remove the bracket to get 88 minus 40y minus 3y equals to 2. In the next step, we perform the required mathematical operations to get 88 minus 43y equals 2 so that minus 43y equals to 2 minus 88. Now the negative 43y is equal to 2 minus 88. That in the next step becomes minus 43y equals negative 86. Now in the next step, we can cancel out negative from both sides of the equation to get 43y equals 86. Then again divide both sides by 43 to get y equals to 2. As already shown before, we substitute y equal to 2 into equation A and we get the value of x as 1. Hence the solution to the system of linear equation is once again x equals to 1 and y equal to 2. Now it is to be noted that the solution to a system of linear equations represent the coordinates of the intersecting points of the two lines representing the two equations.